Good morning again, and thank you for joining us today. My name is Lisa Shaw, and I'm on the marketing team at SICK. SICK is a leading provider of sensor solutions. Today, John Callum, a market product manager for Analyzer and CGA systems at SICK, will be answering your CEMS questions. For example, should you go with an in situ or an extractive CEMS? Do you need a shelter to store their equipment? And so much more. Also, as an added bonus, there'll be real-time live Q&A with the presenter and a panel of SICK experts. Just a little housekeeping before we get started. If you have any questions during the presentation, type them into the Q&A box on the right-hand side of your screen. We'll take some time at the end to address as many questions as time allows. Also, this session will be recorded and it will be emailed to you following today's presentation. Now, without further ado, we'll turn our time over to our presenter. John, please take it away.
Thank you, Lisa. Thank you for that introduction. I also have a panel of experts with me today, two of our market application engineers, John Chitty and Nat Deggs. But today, we'd like to talk about what you need to know before starting your next CEMS project, but we're afraid to ask. Just a little bit about Zick, how it all started. It started with an inventor, Erwin Zick, the founder of the company. And he started it in a shed or garage. Started out with humble beginnings, but as you can see, a great success story. Now we're over 10,000 employees and 1.75 billion euros in global sales, and have operations all over the globe. Many patents, a lot of money funnel into R&D for new products. Just to kind of go through some of the products, if you noticed on that former slide, there's 40,000 products plus. So lots of sensor technology. Presence detection, measuring millimeter to a mile accurate distancing. Industrial safety light curtains to protect personnel from in manufacturing areas from possible bodily harm or death. And then analyzers, which we'll talk about quite a bit today. CEMS analyzers to protect the environment, and also process analyzers to optimize processes. Also world, global leader in custody transfer with utilizing ultrasonic flow meters for custody transfer, and also measuring other medias, and also flare flow monitoring. We also have an app integration so people can customize our products for non-standard applications. We have a systems group that takes not only our sensors, but incorporates other manufacturers' sensors into complete systems for solutions for customers. And then we have motion control, linear and rotary encoders for measuring motion control, and then a complete ID, 2D, 3D cameras for recognizing objects, barcodes, and things of that nature. Also, we have a unique incubator for new businesses. If you come up with a good business plan and sell it to the management board, they'll fund it, give you seed money, and let you execute it and see if it can become a standalone business. So today, I'm going to give a high-level view. I'm using the Zick analyzer portfolio because it was, what I had at hand. But there are other analyzer manufacturers, obviously. But at the top, we talk about we have our in situ analyzers, meaning it's in the process or in the stack. We have probe style as well as cross duct sensors for depending on what application you have. And then we have extractive, full line of extractive analyzers for applications where you have a lot of dust, like in cement and waste, complete line of dust monitors, and also combustion control using the zirconia O2, and then complete systems utilizing either hot wet or cold wet or cold dry extractive technology. So if we get into the reason for the measurement, it's for continuous emissions monitoring would be to meet the regulations, EPA regulations in the petrochemical refining markets, that's typically the 40 CFR Part 60. So if you have process heaters, steam crackers, incinerators, boilers, thermal oxidizers, chances are you're going to have a CEMS, and you're going to have to measure components to be in compliance with the EPA regulations. And in this particular industry, quite frequently, you'd have to have Class 1 Div 2 is required, which is an electrical area, hazard area electrical requirement. So CEMS does stand for Continuous Emissions Monitoring System. So instead of saying that being a mouthful, we'll just say CEMS from now on. So what about the measurement for CEMS? We have, like we said before, we have to measure, components such as NOx, CO, O2, and SO2, depending on the fuel source and combustion source. And we might also have to have a SCR scrubber and measure ammonia slip on the downstream side of the SCR. Also, for CEMS in this industry, cold dry extractive is very common for this particular application. We'll talk about other technologies as well. So if you're looking at a CEMS topology, do you go extractive or do you go in situ? So extractive on the left or in situ on the right. So you have both technologies. Both are offered by ZIC and for other manufacturers. But you have to decide if a hot wet extractive, if you have a really dirty sample, it's good. You're keeping the process gas hot and above dew point all the way from the probe, all the way down the sample line, all the way through the analyzer. So if you do have acid gases such as HF or HCl, they don't condense out. They stay above the dew point and can be measured. And if you use cold dry on those particular applications, you would drop out the component that you wanted to measure, which was the acid, and also you could create a corrosive environment to heat up your sample system.
I might add something there.
Go ahead, Matt, please.
So hot wet is a very good application for things that are soluble as well. If there are aggressive gases and things that might eat your analyzer system or sample system, but also things that are water soluble, that you're going to lose them to some extent. SO2, but ammonia is particularly sticky. It sticks in the sample lines. It absorbs and desorbs in unpredictable ways. To send calibration gas to the probe and back it takes a long time to stabilize, but and ammonia that's in the sample can stick in the lines and cause an offset when you're trying to do calibration checks or things like that. So if you keep those things that are soluble in a vapor state through the analysis of the analyzer, you avoid those problems such as ammonia salts forming and things like that.
Yep, very, very good point. Thanks for the comments, Matt. John,
Hey, John, I'll add too, on the hot wet side, harsh samples, FCCUs is one example. Cement plant stacks is another example. The hot wet extracting system, there's no sample system, so there's fewer components there, there's less maintenance, and it's just a better overall analyzer for harsh type samples. If you're burning natural gas, cold dry is fine, but if it's coal or anything that makes a pretty rough sample, the hot wet extractive is a better solution.
That's an excellent point.
Yep, couldn't agree more. Thank you for the comments. I appreciate it. So when you're evaluating a vendor for a CEM system, as far as their capabilities, you definitely want to make sure that you go with somebody who has good engineering support. They have ability to install and commission and do training and startup. on the job site or remotely. We find a lot of customers will want to have that training at a remote site because a lot of their people that are being trained or there's too many distractions if they're on site, but we can do that either way. Also, make sure that the vendor of choice that you choose, make sure that they have, consumable items and things available during startup that may be consumed because of startup conditions. Then make sure you got plenty of spare parts and they have a good maintenance concept where they can support you either on demand via a preventative maintenance contract or via remote access, which has become extremely important during the COVID crisis. We had to do a lot of virtual service and virtual tech support. So make sure you have 24/7 support from whoever you decide to go with for your CEMS, and then make sure that they can support your installation. They can support you through the engineering, commissioning, and all the way through the life of the CEMS system. So the complete portfolio, this is putting it all on one sheet here. Showing you all the different components that we can measure in a combination of in situ as well as extractive, cold dry extractive and hot wet extractive, and then the dust measurements and flow measurements that we can make as well. Sometimes you have to measure dust and you also have to measure what's going up the stack, speciate what's going up the stack, but then also how much volume. So sometimes you'll need a flow meter. And so we have an ultrasonic flow meter that will measure that flow for you. So some considerations about shelters themselves. So where in the world, right, is this project going to be? Is it going to be at altitude? Is it going to be in a cold environment? Is it going to be in a hot environment, humid environment? How are you going to protect your analyzers? A lot of times you have a complete full shelter. If you do have a shelter building, how many square feet are you going to have? What's going to dictate that? So how much equipment you're going to have? What are the sizes of the analyzers themselves, the sample system, the equipment? How many systems are in that house? What's the electrical area rating? Is it class 1 div 2? Is it general purpose or class 1 div 1? Different design criteria go into that, and also different cost structures for each one of those classifications or meeting those classifications. Also, what type of utilities you're going to have, for power, for air, instrument air. Do you need uninterruptible power? Do you need cylinder racks for cow gases? Do you need safety devices in that shelter itself to protect people that go in and out of the shelter? And then what type of sample systems you're going to have? Are those going to be mounted on the outer wall of the shelter or inside the shelter itself? And then what type of materials of construction of the actual building? Is it going to be a composite material? It's going to be aggregate rock or some type of other material that's going to withstand the environment. John, Nat, open it up to you. Any other shelter questions leaning upon you and your integration experience that wasn't captured here?
Yeah, I'll make some comments. Nobody wants to stand in the rain to turn on the gas bottles and things like that. So rain shields are often incorporated, such as you see there. And all of these add-ons and accessories drive up the cost of your shelter. So those are serious considerations when you're trying to use a shelter. If you have a full inside shelter, is it declassified? Is it general purpose on the inside, or is it area rated, on the inside as well? In other words, the inside's not purged to reach a general purpose classification. So are your analyzers, class 1 div 2 or div 1 by design, or are they general purpose? And what do you need for a shelter? I mean, would a cabinet suffice? NEMA 4X that's weatherproof, that can sit out on the pad or underneath the unit itself. So those are all things to consider when you're thinking about where you're going to store or operate your instrumentation.
Yeah, I'll point out here too, this is a big air conditioning unit, but you can also have heating as well, depending on where you're located in the Gulf Coast. Probably you need the air conditioning more than the heating. But as we found out this winter, we got to -10. Also, you can't rule out, having an extreme event. Then you need to protect the equipment that's inside the building. Also, notice there's a beacon there and also an audio alarm. So that's tied into the safety system. And you could have toxic gas monitors or oxygen deficiency inside so that someone, when they come up, analyzer technician comes to the door, they know that there's a safe environment when they open that door so they don't walk into a condition that could be, potentially life-threatening.
I've seen also, John, some people will have a hole in the shelter, a small port where you can insert a wand
Oh, a sniffer.
test the inside air before you enter. So that's
Okay.
a thought too. And you may have mentioned this. I'm not sure if you did or not, but in this picture, you'll notice the cow gas bottles are on the outside of the building. That's another safety issue. They should be outside. I go into a lot of analyzer shelters where I see the cow gas bottles on the inside, and I immediately prop the door open while I'm in there. I mean, you just don't know if you might have a leak somewhere or something like that. Of course, you can have leaks if they're on the outside too, but it's safer to have them outside of the building instead of inside.
Yeah, that's a serious safety hazard. Not only do your cow gas bottles potentially could leak and empty the contents into the building, causing an asphyxiation hazard, but your sample conditioning system could leak as well. So,
Sure,
you
yeah.
know, if you have high SO2 or CO or methyl ethyl death in your stream, it could fill that confined, essentially a confined space, limited area space, and be a safety hazard.
And
I
as
do make it a habit to open the door and try to find something to prop it open if I'm inside.
And as you mentioned, Nat, there's a awning over this one that protects the cylinders from direct sunlight and also deflects some of the rainfall to protect the cylinders, gas cylinders. Some other options are three-sided shelters, which affectionately we have a nickname for those as a bus stop. But it has a roof on it, has two sides, but the large portion of it's open to the environment itself, and these can be located down in the process units. It's a lower cost initial cost of ownership because you don't have an environmentally controlled area. Just need to make sure that your analyzers themselves meet the area classification. But it does offer some sometimes they'll have lights in here. They'll have some place where analyzer tech could get out of, if there's blowing rain, stuff like that. It won't protect you from the environment as far as heat or cold, but does give you some way to get in out of the rain because most of them have roofs on them. Some of them actually have like an enclosure, like a clamshell type thing that opens up to get access to the analyzers. So you have freestanding, enclosures that you can close the doors up on them, and they protect the analyzers and the sample system itself. Then you have to come out and open the door. Sometimes I've seen the freestanding ones, especially on the Gulf Coast, they have to meet like a hurricane specifications. Withstand a certain amount of wind force, shear force, and some indications in some areas where they expect, tidal surges and stuff, they may be up on platforms a certain distance above the ground clearance.
So I made mention of that this earlier when you're considering how you're going to shelter your analytical equipment, and that is, could a freestanding cabinet such as this be a solution rather than a complete walk-in shelter? The advantage here there's several, but one of which you can be close coupled to the sample point. So this could go up on the grading near where your sample point is, rather than have a 1, 2, or 300-foot sample line. So speed of response would be much lower. You wouldn't have the lag time for the sample transport. And it could get the job done. You know, a NEMA 4X cabinet that's weatherproof, with the proper air conditioning and heating, equipment and or purge to meet area classification, is a good choice, and certainly less expensive than a walk-in shelter.
Yep, that very valid points. This is a lower cost, from an install standpoint, and also, like you said, Nat, you can locate this out in the process and closer to the sample tap, so you can minimize the transport lag time. John, any other observations?
Oh, I'll just mention on this cabinet, a lot of times if it's a rack inside of a building, you'll have, like, the heated sample line will come into the top of the cabinet. When it's a standalone cabinet outside, you want it coming in on the side, because you do not want any penetrations on the top of the cabinet that could be potential leak points for water to get in and stuff like that. So it's just an observation.
Yep, good point.
But it's very common when you're inside of a building to see penetrations at the top of the cabinets, but outside, never.
Yeah, I apologize for the graphic on the right-hand side. I couldn't find a clearer picture, but this is kind of a unique thing that ZIC does for international projects out of Germany. They'll actually get cargo containers, and then they'll build out the sample systems and analyzers. This becomes the shelter, and it's also a shipping container, real shipping container, so they can, when they transport it to remote locations, it makes it easier for them to go ahead and build it in there and then ship it in the cargo container. So we'll have all your analysis equipment in there. It's all built into the cargo container. So if we look at the cold dry extractive, we've already covered a lot of this. I'm not going to spend a whole lot of time on it. But you'd also have to have a DAS, data acquisition system, with your CEMS. So there are many providers out there. I just pulled one off of the web here, CEMView, but there's multiple vendors that's all they do is keep up with the regulations and provide a data acquisition where they take the information from the analyzers and put it into a report package to report to the EPA in the proper format, and extract the information from our analyzers either via analog or digital outputs, and then put that into their reporting package. John or Nat, did you guys want to speak to this slide in any more detail?
I'll just mention that a lot of times we rely on the DAS to do, like, housekeeping functions, handle the daily cow check and the automated CGAs on a quarterly basis, stuff like that. And that's fine, you can do that. But you can simplify your DAS some by having the analyzer itself handle those functions, which we do often at SIC. The analyzer, this BCU portion you see in the middle at the top, is actually a controller, so it can serve that function of handling functions that might otherwise be in a PLC or in the DAS itself.
So these are our different modules for our cold dry extractive for measuring different our components of measure. So you select the proper bench for the measurement. And here's a typical, like a small type shelter. design, or whereas it's a full-blown shelter itself, but it's a smaller building. I've seen some people, instead of using this full-blown shelter, maybe finding a motor control, area motor control center that's air conditioned or climate controlled, and then taking the system itself and then bolting it to the wall into a building. And then this is just a standard package, CEMS package that we would provide, just an example. We have the analyzer on one side of the enclosure, and then a separate side for the sample conditioning system. And then John, that you want to speak to this slide. I know this is one that's near and dear to your heart.
Well, that's a recent one anyway. This is just a 19-inch rack mounted system that was going into an existing shelter to replace an old obsolete rack of analyzers. And you can see the different components in here. That's a rather large sample pump and Permapure brand chiller that was requested by the user. So we're okay if you have a certain brand chiller, certain brand pump, and you have spares for those and stuff like that. Let us know on the front end, and we will build the system using components that you're already familiar with and have stock on. So the only thing you here would be the analyzers themselves. And I'm sorry.
And on this one, we're doing the housekeeping like you referred to earlier.
We are, yeah.
Within the analyzer, so you don't have to have a separate PLC.
Right, exactly.
And it's possible to design fairly compact systems. They don't have to be a 6-foot tall rack. You can use a U bracket for the sample system, similar to what you see there. And that's fairly small, and just mount the analyzers above it. Essentially what you see on the screen now.
So for cold dry extractive, these are our UV multi-component analyzers. We also have filter wheels, so we can do the daily checks without having gas present.
That's kind of an important point there too. All of the EPA performance specifications allow for the use of filters to do the daily validations. You do not have to use a cow gas. So all of our analyzers in situ are extractive, have that as an option. And that's specific to a 40 CFR Part 60, not Part 75. So just keep that in mind if you are looking at upgrading your systems. It's not a bad idea to take a look at using the internal filters to do the daily span checks, because it saves on cow gas, saves on bottles, saves on call outs on the weekends because a bottle ran empty or something like that. So just something to think about. I'm sorry, go ahead.
There's another point I'd like to make about this, and that is measuring NO and NO2 combined together makes NOx, your NOx measurement. And the beauty of being able to actually measure the NO2 as well as the NO is you don't have to have a converter. A lot of times there's an external converter, and some analyzers have an internal converter. The EPA requires on a regular basis that you test the NO the NO2 converter, because it converts the NO2 to NO, and then that NO measurement is made. So a lot of times NO2 converters will fail the EPA check that you're supposed to do. And you have to go to you really shouldn't use NO2 bottles. I mean, it's a quick and dirty check, but you really need, you should really generate the NO2 that you're using to test your converter, because NO2 is highly reactive, and when it stays in the cylinder, it loses its efficacy. So it could be wrong, even though the label says it's certified. After certain periods of time, it reacts with the metal of the cylinder. So generating it is more of a proper way to do it. But if you're measuring the NO2 directly, such as this, then you don't need a converter, and therefore you don't need to do the NO2 converter test that the EPA requires.
Good point. Thanks, Nat. So in the interest of time here, I'll speed up a little bit. I know we got a lot to cover. We want to make sure we have some chance to get some questions in, some Q&A. But we have, Oxor, dumbbell paramagnetic for the oxygen measurement. As John had mentioned earlier, oxygen is a diluent, so we have to measure that on the CEMS systems. This is just another example of one of the, packages that we've put together with, through this case, 3 analyzers in the cabinet itself. It's fairly compact, but we leave enough room for you to get in and work on equipment and to replace the consumables when necessary. So kind of as a summary on the cold dry, a lot of good points were made. Appreciate Nat and John, their experience and bringing that to the discussion here. Typically on a cold dry extractive, you bring the sample to the analyzer and you're dropping out the moisture. So you have filters and chillers to accomplish that, and you're making the measurement on a dry basis for this. And there's a combination of several benches that we would require, most manufacturers will require to measure all the components that are required in the CEMS systems. So it's a cost-effective gas analysis solution, and it's one that's tried and true in the industry, and it's very well accepted. Any other comments on that, Nat or John?
Yeah, as John Chitty mentioned earlier, that this is the highest maintenance type of system between in situ, hot, wet, or cold dry. You have diaphragm pumps. The diaphragms can over time tear or rip, and now you're leaking ambient air and diluting your measurement. Moisture, cold spots in your sample line can cause slugs of water, which can overrun the sample chiller, or which is dropping out the moisture and protecting your analyzer, and also giving you the cold dry sample. So it's a much higher maintenance type of system. Hot, wet, there's you have a probe, a hot sample line, and a heated pump, and you keep everything in a vapor state.
Yeah, with complexity and having more components and more consumables, then the cost of ownership may be higher for this type of device than maybe other technologies. But the initial cost is usually fairly. It's lower than other technologies, but it is a good measurement that's used quite often for CEMS systems, and we do offer a package for cold dry as well as hot wet. A good segue. Hot wet next. Our hot wet extractive analyzers, as John and Nat had both mentioned, have filter wheels where we can do the daily span checks with the filters. Hot wet extractive, we mentioned earlier, good for dirty samples, good for samples that have acids such as HCl and HF that could be condensables that could go away if you cooled the sample. And if they drop out, they can create issues, corrosive issues within your sample system, maybe eat the sample system up from the inside out.
So yeah, and it's worth mentioning again the internal sample filters for daily cal checks and things like that. That saves you on gas. It saves you on cylinder demerge charges. You know, the only thing you need gases for is your quarterly cylinder gas audits. So your daily cal checks, you don't have to worry about your gas bottles running out or paying, you know, rental fees for the cylinders. And it's quick and easy. Somebody from the control room can start a check cycle or something like that. And you don't have
We
to
all
worry
know,
about solenoid valves failing
Yep.
or anything like that.
we all know the analyzer is always guilty until proven innocent. So it's a good way for operations. If they want to do a check, they can do a health check on the analyzer by engaging a cycle, calibration cycle. with
The other
program.
thing is, it says there, we can measure, we can include a hot wet, O2 and total hydrocarbon, FID, with this system as well.
Yep, good point. So yeah, the beauty of the hot wet also usually you're measuring multiple components. And as you mentioned, we have the ability to measure the total hydrocarbon built into the analyzer too with a separate analyzer. And these are example of components: moisture, CO2, carbon monoxide, NO, ammonia, HCl, SO2, and O2. So a lot of measurements can be made with this device. So it becomes a cost-effective method to, if you're having to measure all these components, you can do it all with one analyzer.
The more components you measure, the more cost effective it is. And I would add that this is a short list. If you want to measure something that's not on this list, something exotic, then reach out to us, because there's a good chance that we have a solution to do that.
Good point. So our latest hot wet extractive, the MCS 200 hot wet, has a upgraded color display on it. Also has the ability has a web server built into it. So if you're on the network anywhere in the world, you can access anything that you could access from the analyzer. You can access remotely, and we also have a what we call a telematic data collector, which sends a wireless signal, takes the information via wireless signal, can upload it to a cloud, either the ZIC cloud or a customer cloud or a server on site at the customer site. Become really important in the COVID era to be able to diagnose remotely and repair or make changes remotely, and to monitor when you have analyzers. Responsibility for analyzers at multiple sites makes it a great tool to do diagnoses and to make modifications and changes on the fly remotely.
So there's a couple
Condition
of
monitoring as well.
Go ahead,
What's
John.
that, John?
I just mentioned condition monitoring as well, or you may have a slide on that, I'm not sure.
There's a couple important points here. So this is a web server. It means you could type in an IP address and get to this instrument, see all the diagnostics, start a calibration check, and do any functions that you could do as if you were standing in front of it. But one of the important things is that John Callum mentioned is if you're on the network. So I can't just, from any PC in the world, type in this IP address. You have to be on your corporate network or attached to your cloud or some way, but you have to have access to get to that IP address. So that's important. There's, cybersecurity and all that kind of stuff. So it's not accessible by anybody, but anybody that's on the network that this is on can access this, and it doesn't matter where you're at in the world. And the TDC, the same type of thing. It doesn't have to go to a SIC cloud. It can go to your corporate cloud. And this raises the data because to another level, to a mid-level management, or even all the way up to an upper level management. If they want to see what their plant is doing, and they're in Chicago and they want to see what it's doing in Tokyo and one in Australia and, wherever, then once you load this to the cloud, then they have access to that level of data and to see what's going on with their unit. So this is very, very useful.
Yep, very, very useful tool to be able to, like Matt said, if you have multiple units around the globe, someone is maintaining assets at multiple locations, they can do that, easily remotely, and also getting information to, key decision makers and management as well, and to compliance officers on a global basis. So kind of speed up a little bit here because we're running a little bit on time, but we do have FTIR as well as our spectrophotometer for applications. If necessary, we can employ those measurements as well. So there's a little bit of a comparison between the hot wet extractive with the spectrophotometer and then the FTIR. If the FTIR, you do have to maintain the modeling on it. The spectrophotometer is a little less complex technology, a little easier to maintain. It's no need for specialized personnel. The FTIR is a little more intense as far as having to have the models and calibration gases, and maybe a little less flexible from the standpoint of making changes after the unit's in the field. And it does have a little, well, this is a mute point now because both of our devices now have a ejector or eductor instead of a pump. But both technologies are viable. We have both technologies and can employ them based on which one is best for the application. So summary of the hot wet, we talked about this, where you would use hot wet is nasty, dirty samples, and also samples that have condensable acid gases. It's nice because, as Nat had mentioned earlier, you have fewer components with this because we're keeping the temperature above the dew point all the way from the sample tap, all the way down the sample probes, all the way through the analyzer itself and back out to either ambient air or back to the process. So fewer components usually means less maintenance, maybe a little bit more of initial cost up front, but a lot lower cost of ownership, and you can do multiple components of measure with one device. And
that's key too. Yeah, instead of having 4 or 5 19-inch rack mount analyzers, you can do multiple components in one instrument.
So last but not least is the in situ measurements. So this shows a lot of orange boxes around here, a lot of the in situ ZIC analyzers to make multiple measurements around the stack itself. Some of these are probe and some of them are cross duct. It just depends on the analyte that you're measuring and the range, and also spatial requirements on the application itself.
A quick comment there. So as to our comments earlier about hot wet being less maintenance because there's less parts, I would say on a list of 1, 2, 3, if at all possible, in situ would be the way to go. You're measuring it natively in its natural environment. There's no transport, so you get nearly an immediate response when your concentrations in your stream change, and that would be the way to go. It's not always possible to do in situ, but I would say that would be number 1, and hot wet being number 2, because it's less maintenance, and you don't lose your soluble, and you're not having to deal with aggressive things like ammonia salts.
And we mentioned earlier, some CEMS, like in the cement industry and waste, we have particulate. You'll have to measure dust as well. So we have a full line of dust monitors for that. Also, we have ultrasonic flow meters to measure the volume going up the stack itself. And then this is an example of our GM 700 TDL for the mainly for the ammonia slip. We have 2 different probe versions and also a cross-duct version.
So we have a lot of flexibility there.
Yeah. In the interest of time, I'm gonna speed this up. John, do you wanna take this one?
Sorry, I was muted. That's the GM 700 TDL or ammonia slip, basically. The probe version, you have a probe with a reflector on the end, and the laser will go. I can't do a pointer, but you can see the red line that goes out through the probe, hits a triple reflector and bounces back to a detector. As it goes out, it hits this wedge window, which is the blue angled looking part, and part of that beam will bounce off to a monitor channel that checks how much light is going out. And then if you hit the button again, John, I think it'll bounce to the reference channel. Part of the beam will bounce down to a reference channel that has ammonia in a cell. So it checks, that's for line locking to make sure it's on the proper wavelength and doesn't lose itself, basically. And it's also part of the daily check, daily spin check. So this too can do its own internal zero span drift check without having any cow gas at all in this case. And that's acceptable by the EPA.
Cool. Very important. Interest of time, I'll speed up a little bit. This is a summary slide. We're talking about a lot of these were captured already from John and Matt's discussions, but if you can go in situ, it's going to be your lowest install cost. It's going to be the lowest maintenance. It's a very representative measurement because you're not modifying the sample. You're measuring it in the stack, in the process, and it's usually a much faster response time because of that. For the hot wet extractive, we use that for corrosive, erosive, dirty samples, and for acid gases. The cold dry extractive is cost-effective solution, good for clean streams without acid gases. It's well accepted in the industry. And then this graphic over here shows with the in situ, you just have the analyzer in the process. With the cold dry, you've got more components here. You got more consumables and more things to maintain. And then the hot wet is kind of a good synthesis of the two. It's not as quick as the not as quick as the in situ, but quite quick, and it keeps the sample heated all the way through the analyzer. Is a good workhorse in the industry. So as a kind of a summary, just kind of as a wrap up here, we measure the CEMS to meet the EPA clean air requirements. Air permit is your friend for the source. Identify the gases that you need to measure and what concentrations, and then select your vendors with the CEMS expertise and support, and decide on whether you want to go extractive or in situ. If you want to go extractive, we go hot wet, or do you cold dry? What's the best solution for the application? The shelter that you pick is going to kind of depend upon complexity of the system, how much room you need, and what areas of the country that you're in. What are the weather conditions, proximity to the coastlines, the materials that you need for construction, and then develop a specification that you need, a good tight specification, send it to the analyzer integration vendors for bid. That's kind of the summary for this. So I appreciate your attention. I'd like to open it up for questions. Any questions on the Q&A or chat, Lisa?
Yes, thank you. First, I want to thank you, John, for presenting, and to our panelists, John and Nat, for chiming in with your expertise. And yes, to our attendees, please go ahead and type your questions into the Q&A box on the right-hand side of your screen. And we do have some questions that have come in. The first question I'll read is, what are the typical EPA required tests for in situ analyzers?
John Chitty, you want to field that one?
It's the same as an extractive analyzer. You still have your daily validation that you have to do, although it's greatly simplified because you're just doing it internally to the analyzer without a cow gas typically. And then it depends on the components you're measuring. If it's NOx with UV, you'll still have to do a quarterly CGA. On the TDLs for like ammonia slip, I've had customers petition whatever state they're in for a longer period, 6 months to a year in some cases, on doing instead of doing a quarterly check, you do either 6 months or annually. So it depends on the component, the frequency of the equivalent of a CGA, but you still have to do a CGA either quarterly or annually or every 6 months by putting a cow gas onto the probe. And there's different ways to do that. There's different types of probes. John mentioned there's a GPP probe, which is an in situ single penetration probe that has a permeation filter across the measuring path. That probe, you can do a flood cal, so you can just attach a cow gas externally and just flood calibrate it. The open probe or the cross duct units, you actually, in the case of SICK, you remove the head off of the probe or off of the flange, and it mounts to a calibration box that you introduce a cow gas onto. So the requirements don't change if it's in situ or extractive. You still go by whatever is required by the performance specification. Like NOx would be PS2, and you can look these up online. Just Google EPA performance specifications. If anyone wants to link, send me an email and send you a link to them. But it spells out in there what the requirements are, and it's the same for in situ or extractive.
So if I may, I see a couple of questions here I'd like to field real quick. Will SICK provide probes and heating bundles a full package? And the answer is yes. We can provide complete turnkey solutions, including communications, including any programming, writing of software to help to interface the communications. But yes, probes, sample lines, everything else, we can provide a complete turnkey package. The other one is, what is the limitation of length of the sample lines? And that is a little bit dependent on what you're measuring and what kind of response time you need. So if you're EPA mandated and you have to follow a T90 time, then we can do calculations to tell you what the expected response time or T90 time is, and that would kind of dictate what the length of sample lines are. Other than that, I mean, it's possible to have really long lines. Some of these power plants, most of them that have these really tall 700-foot stacks use a dilution system, but I have seen power plants that have heated sample lines, and so they could be 500 or 600 feet long. There'll be several sections, and there'll be temperature controllers for each of those sections. But again, there's multiple things that would dictate what the sample line length requirements will be.
Great, thanks, Nat, for stepping in. Another question is what is the minimum and maximum sample temperature for the hot wet method?
It depends on the component. We can go as high as 220 C. Normally, it's going to be somewhere between 180 C to 220 C, with 200 being kind of typical. And that includes the measuring cell as well. We heat it to up to a 220 C max, but it's controllable at wherever we need to set it.
Great. This next question is well, let's see. Will SICK provide a maintenance contract? This attendee was saying basically, I'm looking for outsourcing the maintenance work for CEMS vendors.
Absolutely, absolutely. And I see who that's from, and I'll
Okay,
have Don Becker to reach out to him on that.
awesome. A similar or same question from the same person is, can you provide the reference on 40 CFR Part 60 allow using internal filters for daily span check?
Yes, yes, JJ, I'll send that to you.
Perfect. Great. Questions keep on coming in. The next one is, why should I go with in situ versus extractive?
Yeah, I mean, in situ is going to be, the fastest responding, and it's going to be, fairly low maintenance. So those are, two key considerations to go in situ. If you going extractive, has its advantages as well. You can locate the analyzers maybe on ground level in a shelter, and analyzer service techs, prefer to have a environmentally controlled area when they're doing their work on the analyzer. So for creature comforts, extractive is good, and also you can mount the analyzers at grade level, so techs don't have to climb the stack. So those are two that I can think of. John, Matt.
Well, I'll point out there are some reasons in the US that people tend not to do in situ, but let me first say there's some applications where it's just easier and better to go in situ. A sulfuric acid plant, they typically only have to measure SO2. They don't have the requirement to measure oxygen on them. So typically, but that's always by state permit, right? So if you don't have to measure oxygen and you're only required to measure one component, in situ is a no-brainer. If you have to measure NOx, CO, and O2, O2's a dilute measurement to check for air infiltration, plus you have to correct to a certain percentage O2 in your reporting, and you have to report dry. So these are reasons that people don't do in situ. It's because of the number of penetrations it might take on the stack. By all means, if you can get by with just a couple of penetrations and doing a couple of measurements for your CEMS, in situ is the way to go.
Yeah, and as I mentioned earlier, and Chitty alluded to just now, some of them that would be a preferred method. I'll point out again that ammonia is very sticky. It makes salt. It forms salts in your sample lines. There's oftentimes cold spots in your heated sample lines, and you end up with ammonia salts plugging the sample line, or they make their way down to the sample system and they plug and corrode the sample system. You're measuring your component in its native atmosphere or in the stream. And anytime you transport a sample, there's potential to change that sample. So ammonia and soluble things like that, you may be losing some of that to moisture formation, or even in a cold dry system where you're dropping the moisture out, you're losing a small portion of your SO2 or those components that you're wanting to measure. So you might be under reporting your measurements because you're losing some of that sample and you don't know it. When you're measuring it in situ, for one, if I'm controlling NOx by spraying ammonia, then I can use that as feedback for my control system. And, you reach a point of diminishing returns where it doesn't matter how much ammonia you spray, your NOx is not going to be reduced anymore. So you're overspraying it. Ammonia is expensive and to produce or even to transport there, and you're wasting money, but it's also a public hazard. People, it slips by and goes out the stack, and the people in the surrounding neighborhoods complain about the ammonia smell. It's EPA regulated. I mean, all sorts of reasons. And ammonia is a really good example of a way the preferred method would be in situ.
We could do an entire webinar on SCRs and SCR control using an in situ analyzer for the inlet NOx on the SCR to help control the dosage of the ammonia, and then ammonia slip afterwards and NOx afterwards, instead of the traditional way of using chemiluminescent extractive analyzers. You can do in situ, all in situ on SCR control and that ammonia slip. Ammonia slip is unique in that there's not yet an EPA performance specification for it, so it's state permit based pretty much. And we always go in situ for that ammonia measurement. It would be very rare for us to extract it, and if we did, it would have to be hot wet.
It would have to be hot wet. That's correct. Because
so ammonia slip is a really good application for in situ tunable diode lasers, no matter the manufacturer. We all do it. We all make them. We've had some uniqueness with the single penetration probe, but that's
the other thing is, I'm sorry to butt in. The other thing, measurements like HCl and HF and things like that. Why handle nasty things like that when you can measure them directly in the process and not have to transport them and deal with the sample system headaches? So there's a number of reasons why in situ would be a preferred method over hot wet or cold dry extractive.
Great, thank you. That's all we have time for today. Thanks again to our presenter, panelists, and attendees for joining our upcoming webinar. All that information is in the chat. I just messaged that registration link, and you can find and learn about our other upcoming webinars through our newsletter, which I shared that registration link also in the chat.
Hey, Lisa, are you capturing the rest of the questions so that we can follow up with emails to people?
Absolutely, yeah. So any question that was not answered during this presentation, I will share with our presenter and panelists, and they will follow up with you. So thanks again, everyone, and have a great day.
Thank you. Have a good one.
Bye-bye.
Yep.
Bye.
Bye.
See you. Have a good day.